Excellent. Now we're welcoming the next speaker. So we have Dan from Traceable AI. Hello, Dan.
Hi, how's it going?
Good. How are you?
Good, thanks. Thanks for having me.
Great. It's a pleasure to have you here. So I'm going to let you get straight in. So if you start with short introductions and tell the audience what you're going to be talking about, and then I'll meet you back here in about 20 minutes on the stage.
All right, great. Sounds great. Thanks. All right. Hi. Thank you, everyone, for joining. My name is Dan Gordon. I'm a technical evangelist at Traceable AI, which I'll tell you a little bit about in a minute. I've been a developer. I've been in security operations, security architect, product manager for several DevOps products. I've been pushing DevOps since its inception around 2008, 2009, and helped put GitLab on the map most recently. And I've grown my enthusiasm from DevOps to the clear evolution that's necessary, which is still not adopted by everyone, but the notion of DevSecOps. So with that, what I wanted to do today is talk about securing your APIs. Not too different from the talk that we just heard. It is a critical piece of working with APIs and of our applications as we know. And in this new application landscape with microservices and cloud native systems, the connecting pieces are APIs. And again, that's not something that you don't know being at this conference, but let's talk a little bit more about how we make sure that those are secure. So what's changing? What do we need to talk about? As I mentioned, and again, this audience knows that application programming interfaces are at the heart of innovation. It's become clear that that is how we can develop software quickly, dynamically, and with quality, and integrated with all the different pieces that can be provided by different providers, by different tool sets, by different libraries. And they've enabled us to go from monolithic applications to these more flexible, ever-evolving solutions. So for sure, APIs, again, are powering the modern economy. We see that in examples, not just the big players like Amazon and Netflix, where their systems are made of such incredibly complex and diverse sets of services, all talking with APIs. But even in small startups, maybe even especially in small startups, trying to get moving quickly and pulling pieces together. But the challenge is everyone here who is working with APIs already may know this, that this is the future of software development. This is how software is developed. But not everybody does know this. And the key here is not everybody understands the security implications of moving to working with APIs so heavily. So development has adopted APIs voraciously, but in general, security is still catching up. So the current state of most application security is fairly out of date. It's using solutions such as WAFs and RASPs that are in place, and they are solving a problem from yesterday, right? Cross-site scripting, buffer overflow, SQL injection. It's not that we don't have these problems still. Those were the issues we needed to solve when we had client servers and simpler applications and less types of communication protocols between our systems. And the attacks and solutions, like I said, that were based on simpler web traffic, which again we still have today, they're being solved by legacy solutions that just don't understand the API level. And so this not being the world that we operate in anymore, it's now a more complex world with cloud native and microservices, application architectures, can have tens or hundreds of microservices, perhaps even thousands if you're Amazon or Netflix. And each one of those microservices potentially has its own API or is talking with different sets of APIs that are potentially unique. Service written with specific logic, business logic for that service, of which there could be tens or hundreds, written by different people who implemented who knows what level of security. And so these APIs, they introduce basically a new attack surface, if you think about it from that perspective. Yes, we need to keep securing our systems. Yes, we need to keep securing our networks. Yes, we need to keep securing even the new layer of containers and Kubernetes, and the Kubernetes and everything environments. But there's also the layer below that, or in addition to that, which is the communication between the systems, between the services. And so this is a new attack surface that older network edge and edge systems just don't go to. They don't understand. WAFs and RAFs, for example, they're not going to protect against attacks at the API layer because they don't really understand that layer and how those APIs are working. It looks like web traffic to them. And so this has introduced a new set of attacks, such as broken object level authorization, mass assignment, excessive data exposure. And there are versions of many of these in the OWASP web top 10, I like to call it, that WAFs and MAFs are built on. But at the OWASP API top 10 list, which is also out since 2019, these look at these in a slightly different way, right? The attacks at the API level behave differently. And so these challenges can't be solved without really understanding user tracking. Some of these more sophisticated business logic level attacks need user-based tracking and deep application context and state of the session across multiple communications to really understand when an anomaly is happening, when somebody is using the API in a way that is not what it was meant for. And if you look at the headlines in the last several years, it's apparent that these breaches are becoming more common. Between Apple and T-Mobile, unfortunately, multiple times, and Uber and Twitter and Facebook and Shopify, and you name it. They've all been burnt in recent years by API attacks. And you can bet these companies have the latest security technology, WAFs, and they have strong security teams that are focusing on it. These aren't light companies. They know how to do security. So what's happening, right? Security Magazine in a survey, looking at what happened, identified that 91% of organizations had an API attack incident last year. 91%. Gartner analysts, looked at this several times over the last couple of years and said, we predict very solidly that 2022, coming up pretty fast here, is going to be the year where API attacks are the most frequent attack vector for data breaches at the enterprise level. That's staggering. APIs are out there. We kind of sometimes call it the hidden crisis. We're moving along. We're creating apps very quickly. We're putting things together, and we're opening up this attack surface that is easy to miss. And so, what does that mean? So let's dig a little bit deeper. Here's the details of just one of them, right? So this was an Uber data breach. And in the normal situation, in this particular case, a user would basically get on the client and they would get a referral fee, or a referral link, so that they could join Uber using, using a referral. That would then create an ID and pass a user ID back. Hey, we've created this ID. Now the expectation is that client's going to pick up that ID and now come back and request consent details to get the user object, basically, with all the information, including what they need to sign up with, and then they would get that object back and they return it, etc. But an attacker can very easily, with this in this situation, respond with a different user ID, and because Ebola, in this case, because the API was not actually checking that the user requesting has permissions to get what they are requesting, pretty typical standard Ebola, it went ahead and said, sure, you wanted 5, 6, 7, 8, 9, here's that user object. Now, there's actually two vulnerabilities at play here, right? Broken object level authorization, because again, a user who was authenticated was able to request access to data or an object that they were not authorized to actually get access to. But then, and these two oftentimes go together very well, what happened is they were sent the object. Now, in this particular case, again, in excessive data exposure, it's convenient. Our languages make it convenient for developers, for us to get the information and to do what we need to with it. And sometimes convenience, oftentimes convenience can be more risky. In this case, the whole JSON object of the user was passed back with all of their information, with the expectation that the client would do the right thing, filter out and get just the information they need, throw away the rest. That's more efficient, right? On the backend side, it doesn't need to filter through. It passes that work off to the client. Problem is the client was actually attacking, was rogue, and got access to the user's personal identifiable information, the authentication tokens, basically a full account takeover of any Uber user. So this is just an example. And if you look at it, right, if you look at this, the line on the bottom here, to anything that's looking at web traffic and URLs and whatnot, this looks like a completely legitimate API call. It is a completely legitimate API call, but there's context around it that needs to be known. There's context around the intent of the application that is missing to something that's only looking at what's coming across the line, right? The URL, the post. And so that's where that problem gets caught, when you find that what's being requested is not actually allowed to be requested by who's requesting it. And that takes understanding the context. And here's why it's more than just looking for a mismatch in the user ID versus the client ID. Because if you think about it, there is a user who should be allowed to actually do that. And that user would be an admin user, right? So there's different use cases and instances where this has to be looked at and understood from a contextual perspective to really catch the problems. So really, what does this come down to? This means that in this next level of application security tools, we need to have tools that are API centric. They need to understand what's happening at the API level. They need to be learning, not rule-based, because APIs and attacks are changing far too quickly. And rule-based solutions are barely keeping up as it is. When you think about rapid development cycles, DevSecOps, CI/CD, we're able to much more quickly change the communications between the different components of our systems. And all of those different components can actually be changing and upgrading on their own. So there's different change that happens within the system as well. So in order to really keep up with that and understand how things relate and be able to find anomalies and flag issues, it needs to be a learning system. We need to understand the data flow and where our data is at risk. Being able to understand not just when it leaves our borders, when our sensitive, first of all, what is our sensitive data? Second of all, and that's important from a compliance perspective for sure, but also from a protecting your data perspective. When does the data leave our borders is important, but also what's happening internally, because there can be internal attacks as well, and data can be compromised and exfiltrated internally. And so it's important to understand the data flow. And as it gets passed, we're not passing critical data from one server to another trusted server anymore. Now it can be passed and manipulated between tens or hundreds of services that each could potentially be doing something we don't want it to, or getting access that it shouldn't be having. And so we need to understand how our data is flowing through a system. And it needs a solution like this needs to really be able to move at the speed of DevOps. Needs to be aligned with DevOps teams and DevSecOps in order to achieve DevSecOps. Because again, at the speed that development is moving, in order to work together to secure applications as early as possible, we need to be aligned with all the data and be able to adapt and move and test and validate with the speed that development is happening. And that includes documentation of the APIs as well. So these are important things that need to come together in a solution. We have our solution, which we call Traceable AI, which we believe handles these items very well. It focuses around three main pillars: visibility, protection, and analytics. Visibility is about knowing what you have, because you can't protect what you don't know you have, what you can't see. A common problem we find is that there are APIs out there that are no longer used but are still available, perhaps from testing, but they're public. Right, and this is one of the OWASP API top 10 issues of inventory management effectively. Um, if you don't know what you have out there as far as exposed APIs, you also don't know what risk levels you have. It's important to know of your inventory of APIs that are being created constantly by your development teams, what is out there and what are the risk levels? Are they handling sensitive data? Are they authenticating properly? Are they authorizing properly? Right. And so it's important to know what you have, to be discovering that constantly as well. Because here's the thing, uh, it's great that we can document and auto document and use Open API, Swagger, for example, but it has to be done and it has to be kept up to date. And that's good to start as a documentation, but you also want to validate what's live, what's real, what's happening. And so being able to continually discover and do risk assessments and understand your data flow and where your sensitive data is moving, and which APIs handle them is an important part. And then protection, AI first protection, again, as I mentioned, because things are changing too fast to be managing by rules. Nobody wants to have to put changes in for issues that they need to be tracking, or updating it for the changes that they make. So with AI, we're able to find known and unknown attacks, and very low false positives. This is protection against the OWASP, again, I like to call web top 10, as well as the OWASP API top 10, also finding anomalies and many other protections. You can find those on our website. So it can operate as effectively a WAF, but also with much more intelligence and at a level that's more hands-off and far more capable at the API level. And then analytics, and we think this is a really important piece, because we're capturing the data through tracing of all of the transactions, both externally and internal to the system, so north-south and east-west traffic. We're able to piece together the transactions and the traces of everything that's happening, what is talking to what, when, with what data, what details. And so we can, for example, parse a cookie and tell you exactly the detail of the cookie that is being used in a particular transaction. We actually recently had a customer had that come up and provide the ability to actually troubleshoot and identify when the next service in line was actually keeling over because of a piece of data in the cookie that was being passed. And so this level of being able to actually go into this transaction data lake and do forensics and do threat hunting, and have all the data about what's happening during any of the transactions is, we think, very valuable and very critical. This is all based on top of our machine learning platform, and all based on top of a combination of distributed tracing, which we'll talk about in a minute, and also agentless mirroring capability, so we can pull from the edge as most tools can, but also get deeper in and provide more context. And so why is that important? So again, as I mentioned, application context is an important part of being able to properly and effectively find these issues, these new API level issues and business logic attacks. And so we start with understanding the user activity, which gives us a view of what's coming in, what's inbound, what are the identities, what devices that they're using, what are the roles and permissions, because you need that to understand authorization. We also need to have API activity. What are the calls at the edge? What are the internal, east-west calls? What are the sequence of those calls? How do they come together? What's the graph look like of all the different calls as any transaction happens within the application? And then where is the data flowing? How does the data flow across those different pieces from the user all the way to the back end and back? What is the sequence calls and how does the data flow across that? At what point does it hit an insecure API? both internally and externally when we're passing it out. And then at the code level, the parameter details, the request response data, errors and latency, the inner details of how the application is operating. We also track from a parameter perspective, for example, what are the typical types of data that goes into these parameters and the lengths of the inputs so that we can identify when there's anomalies. And so all of this comes from different levels of instrumentation that you can do at various levels, either on the edge at the API gateway, through mirroring, but we can also do language level tracing agents as well, or pod level that actually let you see the data from many different angles to give you the real full picture. And with that, going into the behavioral engine or AI engine and the external factors, we're able to understand what is the API behavior? How does the API behave? What is the normal baseline behavior? What's the code behavior, the user behavior, which is an important piece. We actually track user attribution to everything that happens to the best that we can. If there's a user, a token, JOT token, user ID, anything in there, we pull that out and can tell you this user across this time frame, across these connections and IPs, this is the set of behaviors, this is their storyline. What's the data behavior? What is the API risk posture? Which users are more trustable and less trustable? And all that lets us do many different types of protections that we think we know are very important to be able to do. False positive reduction is a piece of that, but ATO, protecting against business logic attacks, threat hunting, forensics, OWASP API and web protection, etc. So where does this fit across the tooling? Well, it does, if you think about the stages in kind of big chunks, pre-prod is pretty much dev, plan, build, test, production, deploy and run, and then, day-to-day is, the day two operations. So there's lots of different tools that work across those, to provide a lot of different capability for security, and Traceable does cut across that. And as we continue to move left for being able to help developers more with finding the problems before they get the code out as they're developing, and more right as we get more and more into day two operations with the data lake and all the data that's out there. This is a valuable tool across the stages. So is this viable across multiple teams? Yes and no. We'd like to think of it as one team, DevSecOps. Yes, that's aspirational oftentimes, but one team with specific needs, because even when they're one team, right, from a dev perspective, the ability to do enhanced troubleshooting and have visibility of the APIs they're working with, earlier detection of vulnerabilities and risky APIs. Imagine being able to have your pipeline stop you and say, hey, you just added an API that's shown to be high level of risk in production. So maybe you should fix that, right? Or being able to look at the list, the huge list that comes back of here's all of the vulnerabilities, and then using risk level catalog, prioritize those and figure out, okay, these are the ones I better fix first, right? And then from a security perspective, of course, being able to be on constant guard, blocking threats, being able to alert automatically when anomalies come up that are real true problems, providing deep forensics, being able to get in and do threat hunting and understand, okay, what exactly is breaking here. And that's actually valuable to ops and dev as well when we're trying to troubleshoot problems and figure out where something's broken, even if it's not a security item. And then again, catching and flagging risky APIs that are getting used or pushed into production. From an ops perspective, these metrics, being able to know, okay, how is the application performing? How is the API communication between this point and this point? Are there issues there? Being able to do compliance checking and auditing, and root cause analysis. So we've got customers that are pretty, that are getting some great value out of this. Being able to proactively, for example, Hauser, next gen real estate brokerage, being able to find and fix issues proactively, deep issues, as well as Nextroll being able to use the unique methodology of the product to really understand what's happening inside their system. So that's what I've got. We're almost out of time. Please feel free to contact me, Dan, at Traceable AI, for any questions. Check us out, give us a call. There's also a white paper here that talks more about this.
Great. Thank you, Dan. You've just done my work. I was about to come and say thank you for the session. We're coming to the end of it. So yeah, if there's anybody in the audience who wants to learn more or continue the conversation, feel free to get in touch with Dan. Thank you for the insights. It was really great to have you here.
Thank you.